You finish your drink. The can is empty. Maybe it goes into a recycling bin. Maybe it goes into the trash. But if that aluminum can enters the recycling system, something remarkable can happen. It can be separated, processed, melted down, and turned into new aluminum products. And unlike many materials, aluminum can move through this cycle without being fundamentally destroyed. So, what actually happens after the can disappears from your hands? The first stop is the recycling system. Depending on the collection method, aluminum cans can arrive mixed with other recyclable materials. The challenge is to separate the aluminum from everything around it: paper, plastic, glass, steel, and countless other objects. The can is valuable, but inside this facility, nobody treats it like a finished product. It's simply a piece of material that needs to be recovered. Sorting systems separate materials using different physical properties. Magnets can remove ferrous metals such as steel, but aluminum behaves differently. It isn't attracted to ordinary magnets. Instead, recycling facilities can use eddy current separators to eject non-ferrous metals from a moving material stream. As the mixed material passes through the machine, aluminum cans are thrown away from the main flow. A few seconds earlier, the can was buried among household recyclables. Now it's part of an aluminum stream. Sorting isn't the end. The recovered cans can still contain labels, coatings, dirt, and other unwanted material, so the aluminum is prepared for processing. The cans may be crushed or shredded into smaller pieces. This reduces their volume and makes the material easier to handle. And now something strange happens. The recognizable can begins to disappear. Its shape no longer matters, only the metal remains. Inside industrial processing equipment, the cans are broken into smaller pieces. The sound changes. The smooth metal containers become fragments. Thousands of individual pieces now move through the system. At this point, there is no obvious can anymore. There is only aluminum waiting for its next transformation. Eventually, prepared aluminum scrap can be charged into a furnace. This is where the process becomes dramatically different. The solid metal is exposed to temperatures high enough to melt it. The pieces disappear into the furnace and emerge as liquid aluminum. The material hasn't vanished, it has changed state. Solid metal has become molten metal.
Molten aluminum looks nothing like the can it came from. It's bright, fluid, extremely hot, and completely uniform compared with the chaotic pile of scrap that entered the process. Before it can become a new product, the molten metal has to be processed and controlled carefully. Impurities have to be managed, the chemistry has to be suitable for the intended application, and the metal has to be formed into something manufacturers can use. The molten aluminum is cast into large solid forms called ingots. The exact form and process can vary depending on the recycling operation and what the aluminum will ultimately become. But the principle is simple. Take liquid metal and turn it back into a controlled solid form. The chaotic pile of discarded cans has now become a massive industrial block of aluminum. But an ingot isn't a beverage can. It has to become sheet metal. Large rolling mills compress the aluminum repeatedly, reducing its thickness and producing long sheets of metal. The machinery is enormous. The metal passes through controlled gaps between heavy rollers. Each pass changes its dimensions. Eventually, the thick block becomes a thin, continuous sheet. And now we're getting close to the beginning again. That sheet can be processed into the shapes needed for new aluminum packaging. The metal is cut, formed, drawn, and shaped into cans. The exact manufacturing sequence varies, but the principle is extraordinary. The material that once existed as a discarded can has returned to the manufacturing system as aluminum sheet, and eventually, another can appears. Look closely at what just happened. A can was discarded, it entered a collection system, it was sorted, processed, shredded, melted, cast, rolled, and manufactured again. The object disappeared, but the material survived. That's one of the remarkable things about aluminum. The recycling process isn't simply about saving an old can, it's about recovering the metal inside it. And there is another reason aluminum recycling is so important. Producing aluminum from recycled scrap generally requires far less energy than producing primary aluminum from bauxite ore. That doesn't mean recycling requires no energy. It still involves collection, transportation, processing, and melting. But the difference between producing primary aluminum and remelting existing aluminum is significant. The value isn't just in the can, it's in the metal. And that's the part most people never see. We see a can for a few minutes, the recycling system sees something completely different. A recoverable material, a stream of metal, a furnace charge, an ingot, a sheet, and eventually another product. The can is temporary, but the aluminum can keep moving through the industrial system. So the next time you crush an empty aluminum can and throw it away, remember, you aren't necessarily throwing away the material, you're deciding where its next journey begins. Because inside that thin piece of metal is something that can survive far beyond the product you originally bought. This is Material Unknown. Every object has a story. We uncover what happens next.